Yeah, my name's Amanda Owen, and I'm a lecturer in sedimentology in the School of Geographical and Earth. I'm the academic lead for recruitment in the school. So if you have any questions at all, please do not hesitate to contact me. So as Cheryl has already kind of addressed, we have this structure at University of Glasgow, a very flexible degree structure where you study a number of subjects in your first year. So if you come and do either geology or environmental geoscience with us, you'll study earth science in year one. And then alongside that, 2 other subjects from the College of Science and Engineering. Geography is a really popular second subject. And when you go into year 2, you drop one of these subjects, and again, geography is a really popular second choice to go alongside earth science. Now, at the end of year 2, this is where you decide whether you want to take on environmental geoscience or geology as your degree option. And the really important thing is that you get to experience both of these subjects within earth science under that banner. So you're making a really informed choice as to what it is you want to go on and study in detail and graduate with. At the end of 4th year, you'll graduate, or you can stay with us and do an MSci in either environmental geoscience or geology. Now, a common question I often get at Open Days is, what is earth science? It's not a mainstream school subject in its own right, but it is actually present in a whole host of these mainstream subjects. And that's because earth science incorporates aspects of geography, biology, chemistry, computer science, mathematics, and physics, all together to understand Earth's past, its present, and its future. So it's a really diverse subject area. So for example, you may study ice cores and the chemistry within those ice cores to understand Earth's past atmosphere and how and why that's changed. You may study aspects of biology when looking at evolution. You may employ computing science to model the subsurface or the processes that are happening on our Earth's surface. So it really is a very varied subject area that incorporates many aspects of other subjects. And this is all with the fundamental aim of, like I said, understanding Earth's past, its present, and its future. So to demonstrate that, for example, we can look at old or ancient volcanic deposits, understand how those deposits are formed and the processes involved, their spatial distribution, to help us make informed decisions as to what volcanic hazards potentially in the future might hold for us. Equally, we can study past climates, understand how climate has influenced environmental systems such as rivers, to understand what might happen in the future. Now, I know I've kind of mentioned a whole host of subjects there, but you really don't need to be an expert in all these. It's not possible to be, and we know that. So when we are, for example, talking about understanding chemistry and ice cores or computing science applications, we assume you have no prior knowledge above standard school level. So we build these skills in while teaching you these core concepts. You know, another example might be, for example, planetary geoscience. This is something that you may have learned in physics, the development and evolution of our solar system and planet. But that's actually within this earth science remit. And we've actually got a very strong planetary geoscience research group at the University of Glasgow. So I'm just going to talk through the geology degree program to begin with. And geology is essentially the study of the Earth and its structure. So from the core right up to the surface, its composition, its history, how it's changed and evolved through time, as well as the hazards and resources associated with our planet. And this really focuses on understanding whole Earth processes in 4 dimensions, linking deep Earth and those processes to its crust, how the crust has been broken up into tectonic plates, and then interacts with surface environments with application to geological and social environmental problems. So if we think about it like an egg, geology is the whole egg, whereas environmental geoscience is fundamentally just looking at the shell of the egg, but understanding what's going on underneath that shell. So environmental geoscience is the study of the Earth system, in particular the interaction of geology with surface processes and environments and associated natural and anthropogenic change. So, for example, in environmental geoscience degree program, you'll focus on the study of climate change, particularly in the last 2.5 million years, water resources, how we identify them and importantly protect them, landscape dynamics, how tectonic processes might affect the evolution of the landscape, in particular river incision, And again, bringing us all together with environmental and natural hazards, the impact on our society. So in terms of the degree structure, in first and second year, you'll study earth science, and this incorporates aspects of geology and environmental geoscience, importantly giving you a flavour and fundamental background in course concepts within the subject area. And you'll study things like, for example, the evolution of our Earth, natural hazards such as plate tectonics, volcanic eruptions, but you'll also look at, for example, how we can be more sustainable for the future. How can we use Earth's resources in a natural, sustainable way? And these themes go throughout first and second. And then you will obviously take your other subjects alongside Earth science. But at the end of the second year, this is where you make that informed choice as to whether you want to go down the geology or the environmental geoscience route. Now, when you get to third and fourth year in geology, in third year, the options don't have any options. They are core courses, and this is because you do need these fundamental skills and knowledge base before you go on to do your fourth year options. So when you start off, you'll start off with sedimentary geology, which I teach. And what you'll do is I'll teach you how to understand and identify past environments in the rock record and how those environments have changed through time. What's driven the change? What's the impact of sea level rise been on that delta? You'll then go and study igneous geology and understand, for example, volcanic hazards, evolution of mantle melt, and also the resources associated with these processes. Then in second term, you'll go and do metamorphic and structural geology. And this is where you'll learn about how we deform and break apart rocks. And again, this has got application to resources. A lot of the metals and fluids are concentrated along these kind of fault zones. And then to top off the end of third year, we bring this all together in a stratigraphy and tectonic synthesis. How can we bring all of these subject areas together to answer big questions? And these aren't just applied questions, they're also academic questions. In between third and fourth year, you'll undertake an independent dissertation project, which I'll talk about a little bit more in a minute. And you'll hand in that project and work on it in the fourth year. You'll then undertake two core courses, the first one being minerals, metals and materials for sustainable futures, and the other one basin resources and sustainable futures. And this is largely associated with the resources that we get from our planet, but we have a really strong belief that we need to teach you how we can be sustainable and look for more sustainable resources to move forward as we go into a much more climate conscious society. You'll also then get to take some optional courses. Engineering geology is a very popular one, as is planetary geoscience. Like I said, we've got a very strong planetary geoscience group here. And then you either graduate with your BSc or you can stay with us and do a fifth year, an MSci year. And in this year, you'll undertake an independent research project, which would compose about half the credits for the year, but you'll work alongside a member of staff, working with them in active research areas. You'll also undertake analytical methods and geoscience communication. So you'll take advanced courses in how we analyze data, but importantly, geoscience communication as well. What's the point in us doing all of this science if we can't effectively communicate it to the general public? And then again, you'll have some optional courses to choose from. Now, in environmental geoscience, in the third year, you'll start off studying landscape dynamics, which is another course that I contribute to. And as I've said before, this course really looks at the interaction between how our landscape evolves with our future landscape development. So, how does a river respond to tectonic plate? It's an uplift. How much landslides are associated with that rapid degradation of the landscape? The other courses are hydrogeology and environmental aqueous geochemistry. Water is arguably our most fundamental important resource on our planet. So our students on the environmental geoscience course understand where we can find these resources, but importantly, how we can protect them from pollution. You'll also study quaternary geoscience, which is looking at how our planet's evolved in the last 2.5 million years. And then you can also undertake some optional courses, which can be from either geography or from the earth science side of the school. Like the geologist, you'll undertake a dissertation in between your third and fourth year. and then you'll hand that in the 4th year. The other core course that you'll do is Geo-Environmental Policy and Planning, and it's really important that we teach our students not only the core concepts and knowledge base, but also, you know, how do we put all of this into practice? There's got to be a practical element in how we implement policies based on science. And the other option that the students do is Climate, Past and Future, where they'll go into a lot of detail to understand how climate has changed in the past, what's that impact, and what can it tell us about what's going to happen in the future. Much like the geology degree, you can either graduate at the end of 4th year or stay with us and do your 5th year MSc, MSci with us. And these are very similar courses, core courses in terms of your independent research project, undertaking analytical methods and geoscience communication, but you also get to pick some optional courses from our master's courses on offer in the school. So talking about the degree structure, I talked about the dissertations, and you undertake your dissertation in between 3rd and 4th year. And this is independent work, but there is staff guidance in setting that project up, and also we are in contact throughout the summer if need be. And we really want our questions to be problem-based questions. So for example, if you're undertaking the environmental geoscience degree, you might study something like how has legacy lead mining affected water quality in an area. If you're undertaking the geology program, it might be trying to understand the influence of sea level change on the sedimentation and environmental evolution of the Isle of Skye. And the students will get support on this throughout the year and then hand that in the 4th year. So an example timetable, you might wonder how we actually do all this teaching. So this is just an example from 3rd year. So you can see in the mornings that students will attend lectures or workshops or labs in some kind of combination. I know there seems to be a lot of white space in the afternoon there, but we're really mindful of the fact that a lot of students need to work, and that's to kind of give those students an opportunity to work, but also this is where students will undertake further study. This is where, for example, students might have to take, might do further work on reading or on concepts that they've learned in the lecture, workshop or lab environment. But this is all guided by the staff. The staff kind of give indications as to what that further self-directed learning will be in the afternoons or evenings. We strongly encourage our students to come along to our research seminars. As Cheryl's already said, we're a very strong research active school, and we want our students to be incorporated into that ethos. You may have an advisor meeting, or you may attend a society talk. As Cheryl's already mentioned, we've got Glasgow University Science Society, and there may also be a day field trip in there, which often take place on Fridays, but sometimes that can be time dependent, but they are very much present within our program. Now, I've talked quite a lot about the kind of nitty gritty, what it is you're going to be learning, but at the heart of what we teach is skills as well. It's not just all about being book smart on geological or environmental geoscience principles. It's about skills that you come out with from university. So for example, we want to make sure that our students are computer literate through teaching them how to use geographical information systems to map spatial data. We also teach our students aspects of coding. I know that sounds scary, but we absolutely assume that no student has any prior experience in coding, because this is the future. And coding and using computers will really help us excel in how we solve earth science related problems. We also teach our students how to handle big data. With the increase in technology and monitoring, we're getting bigger data sets, and it's a whole new skill in knowing how to handle such data. Our students also are able to think in 4D. This is how things change not only in space, but through time, which is actually a really unique skill set to earth scientists. And also we use industry standard data sets and equipment. We want our students getting hand-on with these things right from the start so that they can go out into the job market with that experience already behind them. We also make sure that we have what is often called softer skills, which I think is maybe not the best way to describe them, because they're really, really important skills. We'll teach our students how to be leaders, how to take a key leading role in a project, for example, how to communicate effectively. And this isn't just about standing up and giving talks, but also written communication, how a report in one area of industry may be very different to another area, which is completely different to how academics communicate their work. They'll learn team working skills as well as being able to work independently. And there's also going to be aspects of project management in there. They'll be given projects that they have to deal with and evolve through time. And the last skill is actually dealing with risk and uncertainty. Earth scientists often work with quite limited data sets. Just because we're working with the subsurface, we only get very small insights into that subsurface. And our students are trained to deal with not only what they can do with that data, but what they can't do. And that actually makes earth scientists very employable in areas outside of the geoscience job market, for example, in finance or insurance, because they can understand the limitations of data, but also what they can do with that data. We also have a number of field courses, so the students will go and apply the concepts they've learned in the lecture and lab environment in the field. And Glasgow is a fantastic place to do that. We've got a variety of amazing locations right on our doorstep due to our location, not only near the Highlands, but near historical mining sites. And this allows us to really let our students practice through learning in the field. And these trips, the students really enjoy. It means that they can go out, experience it, and then come back and think about it when they get home. We also have a series of residential trips. These are both in Scotland and further afield, and the trips are subject to change with changes in staff and expertise, and obviously what might happen in the future in terms of costing. And students really enjoy the abundant experience of going away, not only with other students, but with staff as well. We're there the whole time with them, learning with them, teaching with them, and also getting to know them. And this really further solidifies the skills that we've been teaching them. But it also allows us, by going on residential trips, to tackle larger problems that can't just be done in a day. So example of places that we go at present include Isle of Arran in second year. In third year for Earth Science, go to Southeast Spain. The geologists currently go to Tenerife and northern Spain. And all trips will tackle a problem or a key question that the students will be given before they go out, to then learn how to collect the appropriate data and methods to use to answer that core question. Now, there is a cost associated with field work. So for the geology degree course, this is about $1,300 to $1,600, but this includes the cost of the dissertation as well. We've tried to factor that in. We want to be upfront about what the costs are. Now, these costs will change subject dependent on how the students, for example, do their summer project. Some students go in quite expensive accommodation, some students go in much cheaper accommodation, and some share in groups, larger groups than others. So it's really a ballpark figure. The environmental geoscientists is slightly lower in cost, somewhere from £1,000 to £1,500 for the BSc program. And these are subject to change, but students will always be informed well in advance to what these costs are. We are very conscious of these costs and strive to make courses as cheap as possible without detriment to the science. In terms of facilities, we've got 4 fully dedicated laboratories, which students have 24-hour access to. And in these laboratories is equipment such as thin sections or rock samples that the students can work on in their own self-directed time. Now, we don't promote them working 24 hours, but we understand students have jobs to get themselves through university. So that's the reason that they're 24-hour access, to help them work around other things going on in their lives. We've also got Rock Around the University, which we believe is unique to University of Glasgow. A lot of people wonder why there are these random rocks around campus, and it's actually one of our big exercises that they undertake in second year. The students go out and map those rock types and answer a question as to where they would, for example, go and prospect for water resources. And it's a fantastic resource. We've been able to set this up and allow our students to learn outside, seeing the rocks without taking them too far away, in the comfort of the university campus. We've also got collaboration with the Hunterian Museum, who help us provide world-class samples. You can also study abroad with both the Geology and Environmental Geoscience degree programs. There's more than 250 universities to choose from. So examples include University of California, Otago, Melbourne, or Hong Kong. Now, students commonly go in third year for their year abroad, but it can also be done in the second year. But importantly, the study abroad year counts towards their final degree. It's not an extra year's cost. It is included within and contributes towards their final grade. We do work very closely with industry. We have a board of studies, which has members from industry, and we really use that board to consult to make sure our degrees are aligned to future job markets. There's no point us training for students for previous or even current job markets. We need to know what's the job markets in 3 or 4 years' time when students graduate to make sure that our degrees are appropriate. We work with industry standard data sets. So for example, we work with sediment core from the North Sea, seismic lines, as well as taking our students to engineering sites. People from industry actually contribute to our teaching, particularly on the engineering geology degree, which the students really appreciate. They're able to interact with people in the industry and talk with them and get a real appreciation for what future jobs might entail. We also work closely with our career service, and we offer a university-wide one as well as within the school, where we put on alumni talks or mock interviews. And in the 4th year, we've now set up an industry conference day, and this was a great success last year. We had members from different industries come in, and our students presented their 4th year dissertation to them. And this was a fantastic environment for our students to interact with and talk to future potential employers, or even just gain insights into future employment sectors. Now, I'm just going to kind of talk about geoscience for the future, and geoscience graduates are needed to deliver the UN Sustainability Development Goals. Now, there's a lot going on in this slide, so I will zoom in on a couple of sections, but the key thing is our degree programs are tailored for present and future job markets. So, for example, battery technology, solar panels, we all know that this is the way forward, but to get those critical metals, we need a geoscientist, and a geoscientist knows the tectonic conditions, what fluids need to be involved, and where the final product, the metals and minerals, are going to be. So geoscientists are absolutely critical to finding these resources. Equally, we produce hydrogeologists. As I've already mentioned, water is arguably our most important resource on the planet. Without it, we can't be here. And our students are trained not only to identify where these important resources are, but protect them from pollution. A very big employer for our school in particular is engineering geologists. Now, before any kind of infrastructure is built, be it a road, wind farm, a building, you need a geoscientist to go and analyze the ground conditions, as well as understand what's going on in the subsurface and feed back that information into the design and build of the structure. And this, like I said, is a really big employer for us. And particularly as we go forward, for example, we want to put wind farms out in the North Sea. We need to understand the ground conditions that they go in, and that is what our students are trained to do. So in terms of future careers, geologists, as I've already said, engineering is a very big career path for our students. Mining and exploration, as well as renewables, that new emerging market, for example, in geothermal. We do still have students go off into that hydrocarbon industries, but we're actually finding a lot of our students are diversifying within that industry, for example, looking at where wind farms can be placed in the North Sea. And academia is also something that the geologists can go on to do. In terms of the environmental geoscientists, environmental consultancies, government organizations, charity, and again, engineering, geology, and academia. Quite a few of our students go on for further study for master's degrees. And although many go on to masters, we provide the foundation for successful applications to a world-class funded master's program. And we have quite a good success rate of our students getting full scholarships to go on and study in those master's degrees. So the last thing I kind of want to do is leave the students to say something. And these are just screenshots actually from acknowledgement sections within the dissertation. And I just want to highlight a couple of things in here. So one student noted, not once have I ever been turned away from someone's door. The second one in the bottom left-hand corner acknowledges staff who they've particularly bonded with throughout their degree program. And the last one, it states, I would like to thank all the geographical and earth science lecturers and staff that have helped me throughout my 4 years, whether that be taking my first bedding measurement or generally creating a safe and caring studying environment. You're all stars. And for us, that's really important. We really do strive ourselves on delivering world-class teaching and making sure that students feel that we're approachable and that they can talk to us about, for example, future job prospects. So why Glasgow? We've got an extremely high student satisfaction. In fact, we've got the highest in Scotland for geology. Within the school, we actually received 7 nominations for Teaching Excellence Awards in 2019. We've also got award-winning staff based on their research, both at a national and international level, where they've been recognised for their excellent research. We've got staff that actually inform policy. So we've got staff that are panel members for IPCC, staff who are leading the Centre for Sustainable Solutions, and also staff that are feeding in, for example, missions to go and collect samples from asteroids. We really strive for that research-led teaching, and quite often we have summer internship projects that students can get involved with staff research and help build that research. And we've actually had a number of students get on academic papers through this avenue. We are in Glasgow and we want to solve local problems, but we also train our students to be international facing. What are the big global issues in geoscience that we can help with? So for example, the energy transition to greener energy solutions. And we've also had students identified as world changers through their activities. So I'm just going to leave it there. To just sum up, we've got that flexible degree structure. We've got 2 degree programs to tailor interests, transferable employment skills throughout the degrees. Like I said, it's not just about learning the key core concepts, but the skills that go along with that. And these are done in exciting locations in the field, as well as the laboratory and digital environment. And we are Glasgow. We're situated in the west end of the city. I'm not from Glasgow, but I've fallen in love with this city. It's such a fantastic, diverse city with so much going on. There's something for everyone, whether it be walking in the Highlands, attending gigs, or going to art galleries. So thank you very much.